Hello and welcome to Module 14, Lesson 1, so we're on 14.1, and we're starting our Scatterplots unit. So learning what a scatterplot is. All right, making a scatterplot. So the first word here, recall that he set of bivariate data. So bivariate data, that's just a fancy way of them saying that two variables. And we have been dealing with two variables for a long time. Most of the time we call them an X value and a Y value. So bivariate data are used to explore the relationship between two variables. You can graph this bivariate data on a scatterplot. What is a scatterplot? Well, it's exactly what you think. It's plots, points, that are scattered all over. So it is a graph with points plotted to show the relationship between two sets of data. So if we have 0, 75 would be here. 0.5 is halfway between and up at 80. So I'm just graphing these ordered pairs. 180, 185, 1.5, 85, 1.5, 95, 2, 90, 3, 100, and 4, 90. Okay, so if we look at this data, you can see that if we connected those, that does not make one set of data. Okay, so those plots are scattered all over, and we have two different pieces of data. So how many hours were spent studying, and what were your test grades? And as a whole, I think most of you guys would agree that if you spent more time studying, that you would do better. Now, that doesn't mean that everybody who studied an hour would get the same grade. It just means that if you yourself spent no time studying, and then you yourself spent 1 hour studying, more than likely the trend is going to be is that you would do better. So what trend do we see in the data? And we see that the more you study, the better you do. This is a positive trend. The more you study, the better you do. So the more you study, the better results you have. All right, so in the second one here, it's talking about clusters and outliers. What a cluster is, it is a set of closely related data points. So if you look in here, there is a cluster of data. And if you look here, all of these dots are in a cluster. And then we have this crazy dot right here that's all by itself. This dot right here out by itself would be called an outlier. So nobody else's data points kind of fit in that. So this first data cluster right here, the data cluster goes from 40 to 60 minutes. And the second set of data goes from, I don't know, let's say 70 minutes to over here, what's that? About 95 minutes. So 70 to 95. So that's where the interval minutes are, from 40 to 60 minutes. And then this cluster goes from about 70 minutes to 95. Okay, and the outlier is this one in between that would be a little less, what's that, 58, and then maybe 3.1 or 3.2. So we have outliers and clusters. All right, determining an association. So I kind of talked about this positive association, and that the more you do, the better you do. So the more you study, the better off you do. Negative association would be starting up high, and then you can see that this data is following. So this trend line would be a negative association. So think about a candle, and if a candle is burning, and the longer you let it burn, what happens? The height of the candle goes down. So the more it burns, the shorter the candle gets. That is a negative correlation. Or think about a gas tank. If a gas is full, okay, you have a gas tank full of gas, and if you drive 5 miles, the amount of gas left in the tank goes down. If you drive 100 miles, the gas goes really down. So the more you drive, the less gas in tank. Okay, that is a negative correlation. And then some things have absolutely no correlation whatsoever. So however old you are, or however tall you are, like when you're adult, however tall you are, has no bearing on the fact on what you would get on an ACT score. Okay, so we have a positive trend when you draw a line through your data, and you want to have points on top and the bottom and your line to go through that. That would be called a trend line. I think we're going to get to that tomorrow. Okay, so this is a positive association, negative, or no association whatsoever. All right, so let's look at this data here, and what do they say? So Susan asked 20 people if they would buy a product. So she developed something, and 20 people said yes at any given price. So when the price was $2, so just $2 she was going to charge, all 20 people said that they would buy it. Okay, now when it got to $4 a piece, now not everyone's going to buy it. It went down to, I don't know, 17, 18 people said they would buy it. And look, the more she charges, so now she's here at $8. Now only 13 people said that they would buy it. Okay, and if she's going to charge, what's this, $10 in between here, if she's going to charge 10, now only 8 people said they would buy it. If she's going to charge $12, only 2 people said they would buy it. So what's happening here? This is probably a negative trend. Okay, it has a negative correlation, and the more you charge, the less people are going to buy it. Okay, so based on this association, what might happen if she's going to charge $14 for something? What does it look like it's going to happen? Probably nobody's going to buy it. So people go through and they actually do this when they're starting to put things on the market, and they're trying to collect data to see what is going to happen here. And in this one, and where they would make their most fair price point. All right, the scatter plot shows the reading level for height of 16 students and their reading level. So they have 40 inches, 50 inches, 60 inches, and then they're saying here what their reading level is. Well, this would be talking about students, not adults that have hit their height. So when you're an adult and you hit your height, that's not going to affect it. But think about a student. Someone that's only 40 inches tall could be someone that was in 2nd or 3rd grade. And maybe someone that's 60 inches tall is going to be someone that's in 10th grade, 11th grade. So does it make sense that we're talking about 1st or 2nd graders compared to 10th graders? And what's typically going to happen between a 10th grader and a 1st grader? Well, their reading level is probably going to be higher. So this looks like a positive association here. So this is a positive association, and notice that they are saying students, not adults. For 16 students, a possible reason is because the taller you are, the older you are, and that is more than likely going to have you be a better reader. All right, so we're going to just do a couple more sample here about what might you see in your homework. So Bob recorded his height at different ages, and then we can record that below. So when he was 6, he was 45 inches. When he's 8, he was 50 inches. When he's 10, he's 55. At 12, he was 61. And at 14, he is 63. So kind of makes sense. As you're growing up, you're going to have a positive trend. Okay, and then you hit puberty and you're done your growing, and then this no longer applies. Okay, the scatter plot shows people shooting basketballs. Describe any clusters you see. Well, it looks like I kind of see a cluster here, and I see another cluster here. So, and identify any outliers. So it looks like we have an outlier over here. What would this be at? 35, 19. So we have an outlier at 35, 19. So 35 shots attempted, and they made 19. Okay, 2 clusters is where shots were attempted. Let me do this smaller one here without this eraser. So looks like we're maybe about 6 up to, what is that? 6 to 14 shots is one cluster. And another cluster would be between maybe 18 and 24. Okay, so we have two different clusters, one between 16 to 14 shots and the other between 18 to 24 shots. All right, for 5 through 8, describe the association between the distance here. So 1960 to 88. 1960 to 1988. 82, 84, 86. So where's 88? Right in between here. So talking about the data from the beginning to here. Okay, what are we noticing about this association? It looks like it is a positive association because it's going up. Describe the association between the distance jump for the years after 1988. So after 1988, what happened here? Kind of looks like it is going down or it is a negative trend. All right. So is this linear or nonlinear? Both of these are nonlinear. They are scatter plots. And do we have any outliers? Okay, here's an outlier. And that would be in the year, it looks like 1968. And this person jumped 8'9". So in the year 1968, someone jumped 8.9 meters. Okay, that is the outlier. Data that doesn't fit anything else. All right, so what kind of trend does this look like? So can we draw a line through this? And this looks like it is a negative trend. And if we look over here at 11, those kind of look all scattered. And so I would say that there's no correlation here. All right, so that's the end of it. So positive, negative correlation, positive, negative, and no correlations, and then clusters and outliers. These are all scatter plots, plots that are scattered or put on an XY coordinate plane. And remember, bivariate data just means that we have two pieces of data. That's where we often have our X and our Y for our two pieces of data. All right, you have your scatter plots day 1 homework.